Okay, can everyone hear me okay? Great, thanks. All right, well, welcome everyone to our PFAS in Home Garden and Small Farms webinar. We're really looking forward to sharing our research on the issue and answering your questions this evening. This webinar event is hosted by the Ecology Center, the Great Lakes PFAS Action Network, and Sanctuary Farms. We will have links to these organizations at the end of the presentation in the chat. But before we get started, a few housekeeping. The webinar is being recorded, and we will send an email of the recording to everyone that registered. If you have questions throughout the presentation, please write them in the chat box. We will have about 15 minutes after the presentations for Q&A. A reminder that if you need closed captions, you can click on your Zoom to show captions at the bottom of your toolbar. And again, we will put links in the website in the chat box. So additional resources will be available on the Ecology Center and MSU Extension websites. So I'm going to introduce our speakers. I'm going to introduce myself first. My name is Erica Bloom. I am the Toxics Campaign Director at the Ecology Center, and I co-lead the Great Lakes PFAS Action Network. My colleague, Jillian Miller, is the senior scientist at the Ecology Center. Parker Jean is the co-founder and operations director at Sanctuary Farms. And Faith Collins-Nobis is the extension educator at Michigan State University Extension. The Ecology Center has been working with Sanctuary Farms and MSU Extension for over a year, really trying to understand PFAS and soils and fertilizers. We've been working on graphics and info sheets, and we're going to discuss many of these things today. Those can be found at the Ecology Center's website. And again, those links will be in the chat at the end of the presentation. So why are we doing this webinar today? Why PFAS in home gardens? More and more gardeners and farmers are concerned and asking about PFAS, and there's a lot more research now about how PFAS can contaminate the food supply. The Ecology Center started researching this topic and doing some testing over a year ago. And like I said, we started putting together some infographics and decided that a webinar would be important because we could share some of our findings and answer questions. Really importantly, gardening, we encourage home gardening. First and foremost, there are many benefits to gardening at home, community spaces, and the science of PFAS in crops and soil health is really emerging and new research. And we believe it's important to share what we're learning to support efforts to protect public health, our food systems, and the natural environment. So today, our topics are listed. We're going to hear from Sanctuary Farms and why they got involved in our projects. We'll do a very brief PFAS overview, talk about how PFAS can contaminate gardens, PFAS sources and soil amendments, PFAS and plant uptakes, and then we'll end with a few take action items and we'll leave time for Q&A. So now I'm going to hand it over to Parker, who's going to talk a little bit more about Sanctuary Farms.
Thank you, Erica. Hey, everybody. My name is Parker Jean, co-founder of Sanctuary Farms. We're a urban farm in the Lower East Side of the city of Detroit. We're kind of unique in that we actually started as an urban farm, but then got into composting. And we've actually kind of narrowed our focus even more in the sense that our compost operation has outgrown our produce operation. And we've actually formed a nonprofit and we're shifting some of the things that we're doing over to a nonprofit called Sacred Spaces. So the nature sanctuary and the produce operation are going to be moving over to the nonprofit. But Sanctuary Farms is a business. We sell compost. We mainly sell compost to other gardeners and farmers. We're very involved with the urban farming community. And I think we can move to the next slide. Yeah, so as I touched upon some of these bullet points were, compost is really our bread and butter, and it's kind of an interesting story because we got into composting Basically seeing the lack of composting being made, especially within the city of Detroit. Um, most of the people that are selling compost, like in Metro Detroit, a lot of them aren't actually making the compost. They're just middlemen, like the landscape yards. They're getting compost from other places and then kind of reselling it. So when we first started the farm, we purchased compost in large quantities from other operations that were way outside the city. And it kind of put us on this path and encouraged us to see how it's possible that we could create our own compost. And, because we quickly found that there's just a lot of lack of information with compost, and particularly like what goes in the compost and all that. So we've always prided ourselves on being very rigorous about testing the compost, making sure we know where exactly our feedstocks are coming from. And that's how we kind of got interested in working with the Ecology Center with testing PFAS. And PFAS, it was something that I had heard a lot about, but I didn't really know the link. Like I'd heard that there might be PFAS in compost, but I didn't really connect the dots in terms of like, what's the impact of this and like how much information is actually out there. So it was something I was aware of, but I didn't really know exactly the situation with compost. And we're very excited to be a part of PFAS. I mean, we're not excited to be a part of PFAS. We're excited to be a part of the study that's going on with testing PFAS within the compost. Um, it's like it's something I think we all know is out there. We just need to learn more about it and what the health impacts are. Um, and yeah, I think is that the last slide? Yeah, I mean, I'll just keep it super simple and just wrap it up. Like we're um, we're excited to be a part of the study, and we look forward to continuing to work with the Ecology Center as much as possible. And we're grateful that we can be a part of this like solution, but also that we can provide this hands-on perspective because things can sometimes get a little bit abstract with studying. So, this is definitely this is our work. We're our hands are in the soil, so we're very invested in this. Thank you.
Thanks so much, Parker, for being part of our presentation today and just really great partners with Sanctuary Farms. Um, I'm going to talk a little bit about just PFAS in general, just to get us started, and then we will get really into kind of the meat of the presentation around how does PFAS get into farms and gardens. So the problem with PFAS, PFAS stand for per and polyfluoroalkyl substances, and they're a class of about 15,000 chemicals used to make things water, stain, or grease resistant. They were, developed decades ago, and they're in all kinds of products you can see on the graphic here. There are efforts in many states and around the world to ban PFAS in consumer products. And it's important to note that reducing PFAS at the source is really the critical piece of the solution to addressing challenges we face dealing with PFAS in our environment. So just a high level overview, because of their strong chemical bonds, they do not break down naturally in the environment and they circulate in our air, water, and soil for many, many, many years. And as a result, humans can be exposed to PFAS through dust, water, food. Um, there's much research and personal stories about, showing the connection between PFAS exposure and harm to human health. You could see some of the examples of PFAS health outcomes on the graphic. And we're not going to talk much more about human health and PFAS, but if you want more information about the links between PFAS exposure and human health, you can get in touch with the Ecology Center or the Great Lakes PFAS Action Network. I also wanted to just, kind of put a place to where we are. We're talking today from Michigan. And so just to give you some context, there's 341 PFAS, identified PFAS sites in Michigan. And you could see this map, a full map, if you go to the website there at the Michigan PFAS Action Response Team. And if you're concerned that your garden or soil may be contaminated due to PFAS, we recommend, first looking at this map to see how close you are to an already identified contaminated site. And again, the website is right there. But yeah, now I'm gonna send it over to Faith, who's going to talk a bit more about how PFAS can contaminate gardens.
Thank you, Erica. I'm Faith Collins-Novus, and I'm with Michigan State University Extension, and I get to work with farmers that are concerned about PFAS contamination or directly impacted by PFAS contamination and help with mitigation so we could figure out how to keep them farming and producing a safe product. Okay, next slide. So first, let's talk about how PFAS can end up in the gardens and on farms for that matter. Following our little graphic here of sources of PFAS contamination. So repurposed materials, and that could be something like I've heard of carpet being used as a weed suppressant, maybe on like walkways in your garden. Well, carpet often contains PFAS, particularly a little bit older carpet because it's stain resistant, and that's a buzzword. So, stain resistant, grease resistant, heat resistant, water resistant, all those to me start making me think PFAS because that's a really cheap and easy way to make those materials stain resistant. So something like carpet or railroad ties, we might be more concerned about other chemicals than PFAS, but another one would be cardboard. We get asked about cardboard a lot. And everything that you're putting in the garden to suppress weeds does have a risk. So weed mat, pesticides, cardboard. So cardboard, if it could contain PFAS that are intentionally added, like pizza boxes, could contain PFAS to make it grease resistant. But often cardboard is made of recycled materials. So there could be PFAS in the cardboard. Unfortunately, there's not an easy way to tell if there is or not. It's really expensive to test. And so if you use cardboard in your garden, it could leach into the soil, it could be taken up into plants. And so there's no easy way to tell. So that's a risk that you could be taking. And if you're okay with that amount of risk, you really don't want to deal with the weeds, then that's up to you. Water. So Erica just showed the map of Michigan. That'd be the first place I would look. Am I near an identified PFAS site? If you are, you're at a higher risk. If you're on municipal water in Michigan, it is all tested and has to meet quality for PFAS. So this is more speaking to those that are on well water. I think everybody should have a water test if you're on well water. That's the water you're drinking. But you could be using contaminated water in your garden, which would contaminate your soil and therefore your plants. Soil amendments such as biosolids, compost, animal byproducts, they could contain PFAS. I'm not saying that these do contain PFAS, but they could. Pesticides, that's a whole nother webinar. But there's a lot of pesticides do contain PFAS. It's been used since the 80s. It's gotten a lot of press lately, but it's been used a long time. And PFAS are used. It could make the chemical more effective. It could make it stay in solution longer. It might extend shelf life. Those are all really good things. It helps the chemical stick to the plant or maybe penetrate the leaf to make it more effective. So again, there's a level of risk there, and just know that's a little bit unknown because we don't exactly know which pesticides contain PFAS, because if it's added as an inactive ingredient, then that could be considered a trade secret. Soil. So if soil has been brought into the property, or if it was, I hear from a lot of like community gardens that are using land that had formerly been an industrial site. So there could be some contamination already in the soil. So these are all potential sources of PFAS exposure. The risk vary by source and by your independent location. Okay, next slide. So, what can you do to prevent PFAS in your garden? Don't repurpose materials that could have been treated. If you want to be really sure, then don't use that cardboard or carpet or whatever materials it is. They could contain PFAS. Test your water. Again, if you have well water, please test your water. That's your water that you're drinking every day, you're using in your garden. You could ask questions of the retailers or the brands. A lot of times they probably won't know the answer, but you could still ask because the more people ask, then it starts to bring awareness to the retailers and the brands that people do care about this. So that would be things like your compost or your fertilizers or whatever it is. You could check the bag. It's typically not going to say we don't have labeling requirements in Michigan, but you can ask those questions. This is a really important one about composting. So we just heard about sanctuary farms, and some of the work that they did there shows that the foodware, the compostable foodware, often contains PFAS. So you want to look for those that say that they're PFAS free. If you're doing home compost, I'd be really careful about what you're putting into your compost. If it's unknown, I personally wouldn't put it in there, just because a lot of them have been shown to contain PFAS. And then we have some information for home gardeners on our PFAS and agriculture website, particularly if you're interested in sampling, things like that. We've got more information there. So there's our website. Okay, next. And what do you do if you suspect that your soil or water has elevated PFAS concentrations? So first, I would look at that site on the MPART website to see how close are you. If you're near a military base, or even if there was a neighborhood fire that could contaminate the AFFU, so the fire retardant could contaminate the groundwater. You can take samples of soil or water. In this link here, my colleague Katie put together a great website or Excel sheet, actually, a Google sheet of all labs and how long they take and how much it costs, and just so that you don't have a heart attack when you look at it. A soil and water sample is typically going to cost you between $350 to $500 each. There is an inexpensive water sampling home kit out there that's listed on that website as well, but it's not cheap. So just be prepared for that. And if you are going to test your soil, please look at a website or talk to a consultant or somebody to ensure that you get a representative sample and that you're not contaminating it. It could be really easy to contaminate. Like when Katie and I go out and sample, we have a whole list of things. You don't want to wear bug spray or sunscreen or even deodorants. You don't want to have any clothes that are waterproof because you could be contaminating your soil sample. Add clean organic matter to your soil. So there's a lot of evidence that the higher the organic matter in the soil, then the less the PFAS move up into the plant. And so that could be helpful. If you think that your soil is contaminated or you know that your soil is contaminated, I'd consider constructing raised beds and fill them with a clean source of soil. Again, you have to ask a lot of questions about where the soil is coming from to ensure that it's clean. If your water's contaminated, so there are options for filtering. There's some point source, like at your outside spigot, granular activated carbon. If you have a whole home reverse osmosis, that would work great as well. Please do a little bit of reading before you invest in a filter, because depending on what type of PFAS you have in your water, um, a different type of filter may work better if you have long chain or short chain PFAS. So just do a little bit of reading. And I know the MPART site has a lot of great information about filters. And then lastly, wash your produce with clean water. The PFAS, if it's in the plant, is typically going to be on the inside of the plant. You're not going to wash it off. However, any soil that's on there, that's where the PFAS is coming from. So you want to make sure that you're rinsing the soil off or any pesticide residue um, on the plant. You want to get that all off. So a few tips there that if you think that your soil or water is elevated, please get some testing of your water and look into further resources on our website.
Okay, okay, thanks, Faith. We're going to have Jillian take over now. Thanks.
Thank you, Faith and Erica and Parker. I am going to go in a little more depth about how PFAS may get into soil amendments, um, And next slide. I'm I'm going to summarize what we know and don't know about the presence of PFAS in common soil amendments. And that term includes fertilizers, composts, biosolids, manures. It's a broader term, soil amendments. So the chart on this slide is the main feature, and this is an aggregation of a fair amount of data on PFAS in composts and biosolids from the United States. There's a fair amount of research out there in the scientific literature and from a number of different countries. For this, we just chose United States in hopes that it would be more relevant for this kind of talk. The chart vertical axis is concentration of PFAS. In this case, it's the sum of 15 PFAS compounds. And across the horizontal axis are different types of soil amendments. So if you look at the first bar, at the left of the chart, you're looking at biosolid products. These particular biosolid products are sold commercially at stores. They're bagged. They come from a variety of different states and wastewater treatment plants. So places like Home Depot or Menards, you could get this kind of product. You can see from the chart, there's a very wide range of PFAS values found in those products, up to quite high, up to about 200 parts per billion. We have found that's typical with those kind of biosolids products, that many of them contain rather high levels. Moving to the right on the chart, we have the next bar that isn't quite as high as the biosolids bar is compost, but with a significant amount of compostable foodware. That Faith mentioned the compostable foodware, meaning the paper-based pressed fiber is another term. Takeout trays, bowls, plates, there are a number of different things that fall under that category. Those have traditionally been made with PFAS. There are some brands now that have worked to not treat them with PFAS to make them waterproof and grease-proof. But there still are many, is my understanding, there's still many that have PFAS. Then the last three categories are all those little bars that you see at the relatively low levels. The middle one is compost made primarily with plant matter, so yard waste in general, like leaves and other yard waste. The next one, second to last, is compost from three municipal suppliers that the Ecology Center tested. Those are all in Southeast Michigan. Those have largely yard waste as well, although they may have some other sources. And finally, the last category is composted manure. Just a few samples that the numbers are from studies that are published in the literature. So I will go into a bit more detail on some of these amendments, but takeaway from this is that the biosolid-based fertilizers often contain elevated PFAS, and composts are often low in PFAS, with the exception of the compostable foodware. And animal byproducts, in the very, very small number of studies we found, we only found about manure, have been relatively low. Next slide. A little more on compost. The studies on compost, as I mentioned, have routinely found relatively low levels of PFAS, with the exception of containing compostable foodware. And so I've reproduced a graphic from a paper that was published a couple years ago, because I thought it was interesting how it shows PFAS levels measured in feedstock materials that go into compost. So in this graphic, the vertical axis is a sum of PFAS that were tested, 40 compounds in this case. And the horizontal axis we have wood chips and food scraps. as the first two categories that did not have detectable PFAS. In this study, the researchers took food waste from an institution, and they separated out the food scraps or food waste from food contact materials that were in that waste. And the food contact materials are abbreviated FCMs here and included things like those compostable trays and clamshells and similar items. So you can see from the chart that the food contact materials had very high PFAS compared to the others. Therefore, you can imagine if that stuff is mixed in with compost, it is going to elevate the overall level of PFAS. And the more of it that there is in the compost, the more a higher concentration you might get. If there's only a small amount of that kind of foodware mixed in with a huge amount of yard waste, it might not really be very detectable in testing. It might look like just relatively low levels because it's diluted, but that's clearly an important key factor in compost PFAS. Next slide. Biosolids, I mentioned the bagged fertilizers. So just a little more info here. On the right, there's a picture of packaging for one of these products. I'm not picking on eco scraps. It's just an example of the front of a package. Because oftentimes people want to know how can is it easy to identify what I'm getting if I'm picking up something that's called a fertilizer like this? And says a lot of things like eco-friendly and recycled materials. So first, a little bit of background on biosolids. It does mean sewage sludge from wastewater treatment plants that has been treated to kill pathogens. It is the major end product of wastewater. So residential wastewater, everything that goes down drains, laundry, and it also often includes industrial waste in urban areas where there are industrial facilities that produce wastewater, and that also flows into the same plant. So all of that waste gets mixed, goes through various kinds of treatment and separation, and the solids that come out are the sewage sludge, and they can become biosolids that get spread on land as a fertilizer. That can lead to plant uptake and potentially contaminating food crops and animals. And it really doesn't stay put either. PFAS tends to travel far and wide. It gets into surface water near farms if there has been contaminated biosolids on that farm, and it also is found gets into the groundwater. In Michigan, about 50% of all biosolids are used on land, and the other half is mostly landfilled. Next slide. So about those bagged products, these are some terms that we have seen used on bagged biosolid fertilizers to help you understand what you're getting, because it's not always obvious. They don't always have the word biosolids written anywhere, but they might say things like residuals, recycled organic matter, composted biosolids, or municipal waste. There are lots of studies on biosolids that have PFAS contamination being spread on agricultural land, and the widespread movement of PFAS through the environment from that and into plants and crops and food. I highlighted one study on this slide in which soil samples at a shallow depth under the surface were all found to contain elevated PFAS. And then they tested deeper soil down to 90 centimeters, and still about 83% of samples in that range had PFAS. And they found the same PFAS in the underlying groundwater. So that study, I thought, did a good job highlighting the movement of PFAS from the surface to entering the watershed and aquifer. Next slide. Finally, I already mentioned the animal byproduct-based fertilizers. We do need more research on this if we want to be able to generalize or give much advice. We didn't find anything on products other than manure, for one thing. And so for your information, I pulled a few studies, or the few studies that I found that actually tested PFAS in manure products, and wrote the general findings from those studies. So the levels of PFAS were in the either sub part per billion or small number parts per billion for the sum of the tested PFAS, which are on the low side for soil amendments. Next slide. You may wonder, is any of this regulated? And first of all, at the federal level, there are no guidelines for PFAS in soil amendments of the various types. Facilities that produce composts or septage, which means solids from a septic tank, are not required to test for PFAS. In some states, including Michigan, there are some guidelines and rules around biosolids specifically. So Michigan has a system of thresholds to determine whether biosolids from a given wastewater treatment plant are allowed to be applied to land. Those rules are based on PFOS and PFOA, which are the two most famous PFAS chemicals, often termed legacy PFAS or long chain PFAS. They were in great production for decades, and not so much in more recent times, but they're still very widespread because they don't break down, so they're still cycling through our environment. So the regulations, like I said, are based on PFOS and PFOA, not other compounds. If there's greater than 100 parts per billion, those are considered industrially impacted and can't be land applied. Landowners or farmers who receive biosolids are entitled to see the test results in Michigan. And there are some other states that have some limited regulations around compostable materials and sewage sludge or biosolids. Next slide. So now that you've heard me talk about how PFAS might get into soil from amendments, we're going to discuss more about how PFAS can transfer from soil to plants. This graphic is on one of our info sheets, and it summarizes the multiple factors that all influence how efficiently a plant absorbs or takes up PFAS from contaminated soil. So I do want to point out that this graphic is particularly geared toward, if my soil is contaminated, are there ways to reduce uptake into plants? There's a fair amount of research on this, but it is complex. And so the arrow shows from lower uptake to higher uptake, and factors that tend to produce lower uptake, lower transfer efficiency, include the type of PFAS that are in the soil. Long chain PFAS stick to the soil particles more and are taken up less efficiently than short chain PFAS. The plant species makes a difference. Grains, the edible parts of grains, like wheat and corn, tend to have lower concentrations of PFAS than other edible crops in contaminated soil. That's a fairly consistent finding from a number of research studies. And higher uptake in leaves or leafy greens, so lettuces and other things like that. There are varied results for other plant species. Some of the species pictured here, like tomatoes and carrots, they tend to be in a more intermediate range compared to the grains and leaves, but it's not entirely consistent, so we can't give a really clear guideline for that. Other factors that are associated with lower uptake of PFAS into plants are the soil properties. And this is important because these are things that we can affect and are also really good for the soil. Having high organic matter, high porosity, lots of micropores, higher silt or clay content as well. And finally, a natural type of plant tissue that serves as a chemical barrier is present in some plants. It seems like the most well-known one is the Casparian strip. And some plants have this and some don't. And when they don't, they take up more PFAS. Next slide. There's the bullet points repeat a number of points I just made, but just a little bit more about how PFAS travel from soil to plants. It does occur through water uptake. Primarily, that's how PFAS are transported into plant tissues. And that's why the short chain PFAS tend to be taken up more efficiently because they are more water soluble. It's also related to why leaves tend to get more of the PFAS because water transpiration occurs in the leaves. And so there's a lot of water flow there. And when water evaporates from the leaves, it will leave behind a non-evaporable chemical like PFAS. The graphic shows one example from a research study that was done on gardens near a fluorochemical manufacturing plant. So this is significantly contaminated soil. But the interesting thing here is how the different plant parts ended up in the PFAS testing. In the corn crop, the grains averaged 1 part per billion of in this case 12 PFAS compounds total. And then the husk and the cob and the stem and the roots had a little bit more than the grains, but then big jump for the leaves, 57 parts per billion on average for the tested leaves in this study. Next slide. So this has been mentioned by Faith and me as well, but I'll just emphasize it one more time, that practices that protect soil also tend to reduce PFAS uptake. So this is good news because if you're doing all those good things for your soil, like minimizing tilling and disturbance and compaction and having living roots year round as much as possible and adding organic compost, you're not only increasing soil carbon and protecting the soil structure and protecting the microbiome that helps transport nutrients to your plants, you're also reducing PFAS uptake if there are PFAS chemicals in the soil. One example that I thought was striking was I listed here a study where the researchers used purposely contaminated soil with PFAS, grew lettuce, and they found that when they added up to 20% compost to this contaminated soil, it greatly reduced the uptake of PFAS in lettuce. Next slide. Finally, I want to address the question of soil levels and what constitutes contaminated or not, because we say contaminated soil, or if you suspect your soil is contaminated, or if you get a test, well, how do you interpret the numbers? So this is going to be just one way to show context for that question. There are very few established guidelines for soil levels of PFAS. I found that the state of Maine has one guideline for recommending remedial action with a certain soil level for certain agricultural practices. But we think it's useful to know what typical baseline levels are, meaning soils that don't have any known contamination, soils that are maybe out in the woods or farm fields that have never had any biosolids history. Those could all be considered baseline. And so the chart is meant to provide that context. The vertical axis has PFOS and PFOA, just those two compounds due to some data limitations. And then the horizontal axis is categories of soil, starting with Antarctica. It's not zero, but it's very close, very low levels of PFOS and PFOA. And then there was a study that looked a bunch of places around the United States, undisturbed soils away from human activity. Those show a range of values, but relatively low. And I forgot to mention that the vertical scale is a log scale, which really compresses the data, and that was to be able to show the detail. So the differences between the really high and the really low are higher than they look like here. The chart also includes then farm soils. The middle category is a study from Pennsylvania, farms that didn't have any biosolids history. Next to that, to the right, we have Michigan farms with no biosolids history. And finally, the last category, Michigan farms that did have a history of biosolids application. You can see there's a very wide range of PFAS values found in those farm soils that had biosolids. And that's because some of the biosolids were heavily contaminated. They came from wastewater treatment plants that had an industrial source of PFAS. And some of the biosolids came from wastewater treatment plants that didn't have a significant source of PFAS. So there's a wide range that ends up in the soil. But there is a large difference. You've got what we think are the industrially impacted biosolid treated farm fields had anywhere from around 10 to 100 or even close to 200 parts per billion of those two PFAS compounds. And compared to that, then the baseline soils were mostly very low, almost non-detect, up to about 2 parts per billion. A few samples a bit higher, like 3 or 4. So hopefully that gives some kind of range to have in your head, like, you know, subpart per billion up to 2 parts per billion is maybe a baseline where you're not going to find a lot of soils that have less than that. There will be some just variation in samples. Okay, next slide. And I will turn it back to Erica.
Okay, thank you so much, Jillian. Yeah, so we're going to move to the final part of the presentation, and I'm going to talk a little bit more about, what you can do to take action. At the Ecology Center, we always talk about individual action and systemic change, like policy changes or market-based changes. So I'm going to start by summarizing a few points that were made in the presentation for individuals. If you have a home garden or a small farm, again, ask questions, ask retailers if their soil amendments have been tested, or if those results can be shared. Even if they can't provide an answer, it's important for people to start asking so that the retailers know that there's interest in that. Again, a main point to take away: if composting foodware containers, make sure they're PFAS free or don't put them in the compost. We shared some examples of people who are testing soil and wanting to know more. We have resources on labs that you can send your soil samples to. Again, if you live near a known contaminated PFAS site, you could use raised beds or containers and fill with clean or purchased soil, but you'd have to probably want to do, ask additional questions and do testing. Again, thinking about your water, where are you getting your water? Is it contaminated? Consider, installing water filters that remove PFAS if you can before watering your garden. These are just a few things. There are more resources on the MSU Extension website, and we encourage you to follow up there. But the bigger need, is for policy change, and that it can't just be up to us as individuals to take care of this issue. We really need policymakers and regulators to take action. So the Ecology Center recommends, legislatures enact statewide bans to phase out PFAS in consumer products. We need enforceable standards for PFAS in composts, biosolids, soils. Several states have started the process of regulating PFAS in soil, and this has implications for site investigations and remediation decisions. And we need legislation that requires compostable products to be PFAS free and labeled correctly. So there's lots more policy actions. These are just a couple bullets that we wanted to highlight. And we're gonna kind of close out by, here are some websites that we will, put in the chat. If you want to find out more, you can go to the Ecology Center and look at all of our info sheets and websites that we've developed as like a continuation of the material we presented today. The Great Lakes PFAS Action Network, it's a coalition of impacted communities that are supported by environmental organizations that are working on PFAS and supporting each other. MSU Extension, you heard quite a bit from Faith, but really encourage you to go to that website, and there's lots of resources there. And then, of course, Sanctuary Farms, we really appreciate their partnership, and we thank Parker for presenting with us tonight. So with that, I really wanted to say thank you to everyone, to the presenters and the hosts, and all of you for attending. Appreciate you listening, and I hope that you took something out of this presentation. So we did leave time for some questions and answers if there are any. I'm going to stop sharing my screen now, and we can open it up. See if there's anything.
Great.
Oh,
There is one question in there about clean sources of compost or soil. So Erica, Jillian, Parker, do you guys have recommendations on how somebody can find verifiably clean sources?
I don't know about the verifiably part because there aren't any requirements to test for PFAS. So from what we found, I mean, we did a really small sample set, but we did test some popular municipal compost products in Southeast Michigan, and found those results were promising. Because the levels found were on the low side, and we also I can't tell you all of the feedstocks. I just know that all of those places have a lot of yard waste and leaves, so that is a large portion of it, and that is helpful. Like seems like the higher percentage of that kind of yard waste. I hate calling it waste. It's actually very useful, but the higher the percentage, the better. So I know that's not super satisfying, but if you can learn more about what the feedstocks are, you can make an educated guess.
Great advice.
Yeah, are there any other questions? You can put them in the chat, or if you want to.
My colleague Katie just put in the chat a PFAS-free purchasing guide that we found from Massachusetts for their government. And there's a lot of really great resources in there. They put this out for government entities that want to verify that they're buying PFAS-free. So this was put out, I think, just last year, so pretty up to date. Okay, there's a question. Has anybody looked at the product from the large company Dairy Do?
I have heard of that product. We haven't tested it. Um, I'm trying to remember. Okay, so that's an animal byproduct, right? That's like a manure. Yeah, we haven't. The Ecology Center hasn't specifically tested any manure products. I only was able to find a very small number of published studies. So in most cases, the studies didn't even name the products. So I'm sorry, I don't have that specifically. That kind of testing is kind of on our list for future if we have the resources to do more testing that informs.
There's another question in the chat. Does spraying your lawn contribute? So it depends on what you're spraying with. I'll start with this one and let you guys add in. So if you are spraying some type of a pesticide, which could be for weed control or insect control, fungicide, there is a chance that it contains a PFAS. They have been used pretty widely. I think, I don't have the number off the top of my head. I think it's about 50% of pesticides have an active ingredient that's a PFAS. Might be a little bit less than that. Inactive ingredients do not have to be disclosed to the states. So possibly, if that's what you're talking about as pesticides.
Right, I can add a very small story to that. There was a backyard neighbor was spraying or having a company spray mosquito defense. That was the name of the product, which I found out because it was very near a beehive and I was concerned about it. And it took a little digging, but I did find the chemical structure of mosquito defense from True Green, and it was a PFAS, the active ingredient was. So yeah, it is quite common.
Somebody else. So they happen to live next to a confirmed dump site with PFAS in Holly Township. I'm really sorry to hear that. And I hope you've tested your water or the Eagle. If you live near it, hopefully Eagle came out and offered to sample at their expense. Another question or comment, I'm not sure. I live in New York City, and our new citywide industrial compost collection program allows food containers and pizza boxes. It sounds like we community partners should avoid the resulting compost which the city is offering us. Do you agree?
I'd love to take advantage of I'd love for people to take advantage of a city composting initiative. I would be cautious about that. Um, I would question the city about what kind of testing they've done. Uh, I mean, citywide in New York City, that's huge. So, um, so yeah, actually, if you do ask the city about that and getting any information, feel free to share it with us at the Ecology Center. I'd be interested because I would treat that with a bit of caution.
Um, go ahead. Did you have something else, Jillian?
Oh, I just saw another question come through about is there a list of pesticides that have PFAS as active ingredients? Oh gosh, I am just starting to learn about this this whole area. I actually think there might be. I just don't have it at my fingertips, but I can, if you send us an email, I can get back to you because I think something was shared with me that actually did list out. I think it was Michigan specific uh, active ingredient PFAS in pesticides.
I haven't seen anything Michigan specific, not saying it's not there. Minnesota has done a really good review and they list out their active ingredients. And so I could put that in the chat.
Now that you say that, Faith, I may have been thinking of the Minnesota.
I did send that
Yeah.
to you.
Yes.
It's great. So I'll put that in the chat right now.
Thank you so much.
Where does Sanctuary Farm sell their compost?
Yeah, we sell it all over. I mean, mainly in the city of Detroit, but also Metro Detroit. Um, yeah, and going back to the question earlier, I mean, it's funny because it's like, is it clean compost? It's like I think it's clean. I can't, unfortunately I can't say it's PFAS free. And now that we are testing it and everything, it's sad for me. I mean, because we on the one hand we feel good about diverting large amounts of food waste. So we accept food scraps like one of a big food waste hauler, which is Midtown Composting. We accept pretty much the majority of Midtown Composting's food scraps, which is coming from all over. But they're definitely bringing us compostable packaging, so it's something that I would like us to move away from the compostable packaging in the long run. It's just we're so entrenched with some of our partnerships and um, the way we've been operating. It would be very hard to just completely stop or cut out certain things overnight. So, we have long-term goals that we're moving towards. We test the compost for other things. We do the STA compost test, so we're testing it for pathogens and fecal matter and all the macro micronutrients and everything. So, and I mean, I can tell you exactly what's in it in terms of all the feedstocks and everything too. So, we're pretty strict about our recipe.
Thank you. And back to our friend, I think with the dump site next to them. So they have done their own testing on water and soils, and it came back positive. So I would encourage you, if you're comfortable, to not to share those results on this webinar, but maybe to reach out to the Eco Center or to MSU Extension, because depending on how contaminated your soil is, we may be able to help you select plants that take up more or less PFAS in them. And the question was, can we have the township pay the next round? And each township handles that differently. And I know from the state level, if you're in a known PFAS site or an area of interest, then Eagle will pay for the testing of water. They do not do soil for homeowners. And if your water has PFAS above the state regulations, the maximum allowed contaminants, they will also pay for a filter if you're in one of those areas. And so you could check, I think Katie put it in the chat earlier. Maybe she could do it again about where you can look and you could type in your address and see how close you are and if there's a known area of interest or PFAS site in there. So, but if you want to have offline conversations, please reach out to one of us about your specifics. Any further questions? Thank you, Katie.
Any other questions? Well, we're just about at time, so it's almost 7 o'clock. So if there aren't any other questions, we can end a minute or so early. Again, we really appreciate everyone for coming on a Monday evening. And this is really just the start of our conversations. We would really like to be doing more research and more sharing information, more webinars down the line. And so one kind of next step is we will email everyone this recording, and we will send you links to find more information with some graphics and things that you can share too with your neighbors. And again, reach out to the Ecology Center, MSU Extension. I'm sure Parker, would love to hear from you about sanctuary farms. And yeah, well, that's it. Thank you again, and
Right.
have a great evening, everyone. Okay.
Goodbye. Thank you.
Thanks so much.